Today, we will see some examples related to the laws of exponents. Find the value of p using laws of exponents. To find the value of p, we have to solve the left-hand side so that we get only 8 as the base. So let's solve 8 square to the power of 3 multiplied by 8 cube to the power of 4. If we have to simplify 8 square to the power of 3, then which law of exponents should we use? Think a little. We will use a to the power of m to the power of n, which is equal to a to the power of mn, where a is an integer and both m and n are whole numbers. Using this law, we can write 8 square to the power of 3 is equal to 8 to the power of 2 into 3, which is equal to 8 to the power of 6. We can also simplify 8 cubed to the power of 4 by using the same law. 8 cubed to the power of 4 is equal to 8 to the power of 3 into 4, which is equal to 8 to the power of 12. Now we will solve 8 to the power of 6 into 8 to the power of 12. Can you tell which law we use for this? Think a little. Absolutely correct. We will use a to the power of m into a to the power of n, which is equal to a to the power of m plus n law. Using this law, we can write 8 to the power of 6 into 8 to the power of 12 is equal to 8 to the power of 6 plus 12, which is equal to 8 to the power of 18. Now, we see that the base is 8 on the left side and 2 on the right side. To make the bases equal on both sides, we will express 8 as 2 into 2 into 2, which is equal to 2 to the power of 3. In this way, we can express 2 cubed to the power of 18 as 8 to the power of 18. Here again, we will use the law a to the power of m to the power of n is equal to a to the power of mn. Using this, we will get 2 to the power of 3 to the power of 18 is equal to 2 to the power of 3 into 18, which is equal to 2 to the power of 54. Now if we compare the left side and the right side, then it becomes easy to tell that the value of p is 54. Similarly, by using laws, we can solve complex questions. Next example. Simplify this. Let's solve it. First, we will solve the numerator. Looking at the numerator, we understand that 4 cube into 3 cube, the exponents are the same in both the numbers. So here, we will use the law a to the power of m into b to the power of m is equal to a into b to the power of m. According to this law, we can write this number as 4 cube into 3 cube is equal to 4 into 3 the whole cube, which is equal to 12 cube. Now we will solve 12 cube into 12 to the power of 12. Here, the base is the same, so we will use the law a to the power of m into a to the power of n, which is equal to a to the power of m plus n. Using this law, we will get the number 12 to the power of 3 into 12 to the power of 12 is equal to 12 to the power 3 plus 12, which is equal to 12 to the power of 15. Now let's solve operations of the denominator. Since we've expressed the numerator as base 12, we will try to express the denominator also as base 12. According to the law, a to the power of m into b to the power of m is equal to a into b to the power of m. We can write 24 to the power of 5 as 12 to the power of 5 into 2 to the power of 5. Using the same law, we can write 2 to the power of 5 into 6 to the power of 5 as 2 into 6 the whole power 5, that is 12 to the power of 5. Since the base of all the numbers is 12, we can use the law a to the power of m into a to the power of n, which is equal to a to the power of m plus n, to write 12 to the power of 1 into 12 to the power of 5 into 12 to the power of 5, as 12 to the power of 1 plus 5, which is equal to 12 to the power of 11. Now, we will solve 12 to the power of 15 divided by 12 to the power of 11. For this, we will use the law a to the power of m divided by a to the power of n, which is equal to a to the power of m minus n. Using this law, we can write it as 12 to the power of 15 divided by 12 to the power of 11 is equal to 12 to the power of 15 minus 11, which is equal to 12 to the power of 4. So, the simple form of the given example is 12 to the power of 4. Keep in mind that we can also solve this example in different ways, such as rearranging base 6 and 2 or rearranging base 3 and 4, etc. Will you be able to solve the question by using these methods? Try it. Next example. Verify the statement, if the power of a number is 0, then the value of that number is 1. Let's verify it. Suppose b is equal to a to the power of m. Let's divide both sides by b. So, b by b is equal to a to the power of m divided by b. On the right side, we can write the value of b as a to the power of m. Hence, b by b is equal to a to the power of m by a to the power of m. On the left side, b is being divided by the same number, so the result will be 1. On the right side, we can apply the law of division of exponents. Under this law, if the base of the division function is the same, then we subtract the power of the divisor from the power of the dividend and write the result as the power of the base. Like here, we will write the power of a as m minus m, which is equal to 0. That is, a to the power of 0 is equal to 1. This verifies that if a number has a power of 0, then its value will be 1. Today, we have seen examples related to laws of exponents. In the next video, we will see some misconceptions related to them.